And to get us thinking, get us cranking, let's take a look at our problem of the day. Dori has a job that pays $45,000 her first year with the chance for an additional 5% annual raise for the next 5 years. Wow. In the 6th year, what will be her annual salary? So got to think a little bit here. Let's see, we got $45,000. It's going to be her first year, and she's going to get an additional 5% annual raise for the next 5 years. So what is going to be going on in that 6th year? That's what we are interested in knowing, all right? So let's take a look at this thing and see where we're going to go on it, all right? So first of all, we're going to start out with year 1 at $45,000. So it's kind of like an ordered pair business here, all right? We're going to start with year 1. She's making $45,000. Now, the next year, she's going to get a 5% increase. So let's see what that's going to do for her, all right? Let's take it and see how that's going to work. By the way, use a calculator on this one, guys. Let's take it there. At $45,000, here we go. What are we going to be making? Well, according to this, we should be able to multiply by the increase is what? 5%. So be sure you don't give her too much. You got to, 0.05. That's 5/100ths. And let's see what that increase is going to be. Well, she's going to get $2,250 extra. And let's go ahead and add that little puppy together to what she had, because that's just what we're interested in, is how much money did she make. And goodness, we could do this for all day long. See what we've got? Looks like $47,250. Pretty good there. Increase of what? $2,250 spread out over 12 months. May not seem as much, but it's not bad. All right. Now the 3rd year, my friends, what we're going to do is we're going to take this $47,250, multiply it by 0.5, and then add the original. You know, there's another way we can do it that save us a step on the calculator. Are y'all in? I am all for saving a step on the calculator. Let's take our answer and multiply it by 1 plus 5/100ths, 1.05, 1 5/100ths, all right? You say, well, how did that work? We get the whole total plus the interest that way. So let's see what happens if we put in multiply. That's what we're going to do. We're going to multiply it times 1 5/100ths. There we go. So we're up to 4,9,612, and we get 50 cents. So it's starting to fill in pretty well there. So she's making some good money. Notice she got a little bit more over this year than she got as an increase last time, because you're getting 5% of the 5%. So you wonder, now, Ernie, are we going to have to run that through for 6 years? Well, we could do that. We could run it right on through for the 6 years, multiply by 1.05. But let's think about it. Yeah, we'll do one more. All right, let's go one more time here. It's not that hard, is it? So take it, and by the way, what am I doing? I'm back to the calculator if we go, guys. There we go. I'm using this number when I hit times. It just picks up the answer I just had, which is right there, and we're going to multiply it by 1 5/100ths, or 1.05 as we so love to call it. And it's for a whole year, so we don't need to worry about anything else. Now we're up to, wow, 52,093. And there comes that question mark. What do? I say we give her 13 cents. All right, we can work out a penny there, can't we? And we can do that again one more time. Why not? And I see we're going to have multiplying times that. How about it? 1 5/100ths. Press enter, and we're getting pretty up there. So we are now down to year 5, and that's going to give us 54,000. See how quickly your money multiplies when you're getting percent of percent of percent? It's very nice way to go. And it looks like we go one more year, we'll come up with the final total. Give you a mystery there? Hey, why not? Let's go ahead and figure out what it's going to be. And we're going to say times 1 and that 0.5 one more time. Should be about 57,000 something. There it is. Wow. So 6th year is going to be 57,000. That's what she's going to get paid that year, all right? 432, and looks like a little chump change. So that's her 6th year. Remember, 1st year, she's kind of on trial basis. They say, we like you. We're going to give you a raise for your 2nd year, and your 3rd year, and your 4th year, and your 5th year, and your 6th year. Now, who knows what happens here? Maybe they like her so much, they'll start giving her 10% raises. Wouldn't that be nice? Or 6% or 7%, even a little bit better. But that's not a bad increase. That has taken her from 40, basically over $12,000 over 6 years. So that's actually getting closer to what would we have there? Yeah, 12,000. Am I right? Pretty close to that? Something. So that's pretty good increments. And that's basically based over 5 years because she was starting at 45,000. So there we go. And the next year, hey, it's going to be even better. Hopefully. Now, could we have done this without all that calculator work? Some of you are going like, oh my goodness, could we have done that? I think we could. And what I'm going to do, I'm going to go to a growth problem here, a growth situation. We're going to say A for the amount of money she's going to have. And what's happening here, we start off with 45,000. And remember what we did? We raised that, and we're looking at the 6th year. Now, I don't want to put a 6 up there. No, because my first year was right there. So we're going to say, we're going to raise it to the n-1 on this case. That makes this a little tricky. Now, most of the time we just said, hey, what's the, with 5 years, what will we have, or something like that. But this one, we're actually looking for the 6th year, but she didn't get anything the first year. No interest the first year, all right? We waited till the 2nd, the 3rd, the 4th to tally that on, all right? That was part of the problem situation. So let's see what happens when we take 45,000, we raise it to the 6 minus 1, which is going to be the 5th power. Let's see real quickly on the calculator. Do we get the same value here? That's a little bit tricky. It's nice to write the ordered pairs because I think we really see what's going on there from ground zero up to where we are. And let's see what happens in the situation of this problem. I'm going to have some people on Facebook going to say, oh, I took it to 6 years, so why didn't you do that? It's all right. Yeah, you can have your ways to disagree with me. I'm interpreting the problem here. And what do we got? There it is. Same thing we had the other time. We still end up with 57,432 and 67. That's what she's going to get. She'll get that next year raise tacked onto year 7, maybe January the 1st or 2nd or whatever. Got it? So there you go. Problem of the day, solved a couple of ways. We could stretch it out. I wanted you to see what is actually going on, but this is a nice little formula. It's called a growth formula. You start out with where you are, and then you're actually going through, how many times am I going through this 1.05 process? You're actually going through it 5 times, and that's why we want to use the n-1. There'll be other times where you're just working for the interest at the end of the year, then you're going to have 5 years, okay? So that tallies into your current growth. So this one is a little bit different wording. Gave it to you so you would read and read carefully, all right, what's going on. And we also specified for the next 5 years. She did not get a raise the first year, per se, during that first year. She waits until it gets tacked on to her next year. So there you go. And folks, hope that was a good one for you there. Problem of the day solved.